I mean, just everyone need to start. Hello guys, this is Coulomb'S Law. The previous video we did like still 3 point charges, but that one is on a single plane, the x plane alone. Yeah, the x coordinate alone. But for this we have both x and y coordinates. So after this question, I will move to electric field in the next video. So let's just quickly treat this without wasting much of our time. Well, there's a shortcut to this question. Why? Because there is a coordinate that cancel out. I think the y coordinate it cancel out. So if you know it, the kind of question, you can just neglect it and work on the x coordinate alone. But I'm not going to do that. I'm going to solve both the x and y coordinates so that anytime you see similar question that they are likely not to cancel out, you will know how to go about it. So I'm not just going to focus on the x coordinate alone just because I know that the y part will cancel out. I'm going to do both and work them out so that in case you another time you have same question that doesn't cancel out, you know what to do. Now, 3 point charges Q1 equals to 2.0 microcoulomb. Q2 is also Q1. Q2 equals to Q1 and Q3 equals to 4.0 microcoulomb are located at, we are given two coordinates xy, xy, xy. The 0 is 0.3, 0 minus 0.3, then 0.4 and 0. So let's first draw our plane. So the first Q1, the x-axis is 0, the y-axis is 0.3. So the x-axis is at the origin, the y-axis is positive 0.3. So let's assume that our Q1 is here. Q2, x-axis is 0, y-axis is minus 0.3. So the negative y-axis. Let's say this is where the minus 0.3 is, Q2. Are we together? Q3, the x-axis is 0.4. Positive 0.4, while the y-axis is at the origin, the x-axis is positive 0.4, Q3. Let's assume that it's here. So now let's join all the coordinates together, like all the points rather, let's join them together. I hope that's clear. Now we have to find the force exerted by Q1, see, F12 exerted by Q1 and Q2 on Q3. That is the force exerted by, don't forget, this one is also exerting force on them. This is exerting force. But what we are asked to find is the one that Q1 is exerting on Q3 and the one that Q2 is also exerting on Q3. So the force that both Q1 and Q2 are exerting on Q3. So are we together? Now, Q1 is positive. They did not put minus there, so this is plus. Even if they don't put the plus, so far there is no minus there. This is positive, this is also positive. So Q1 is positive, this is positive, this is also positive. This positive is for the charges, not for the coordinate. Don't forget, this is minus 0.3, y, negative y. This positive that I'm adding is for the sign of the charge, not the sign of the coordinate. But this negative y, so that you won't say, this is negative y and I'm putting plus. This plus represents the charge, because all the charges are positive. Now, all the charges are like charges, and what happened to like charges? Like charges does what? They attract, they repel rather. So Q1 will be pushing Q3. So the force exerted by Q1 on Q3 will be moving downward. See the arrow. Because it's a force of repulsion. It's pushing Q3. The force exerted by Q2 on Q3 will be moving upward. Because it's also repulsion. Both of them are plus plus. This one will be pushing it. This one is pushing down. This one is pushing it. Do we get? So they are force of repulsion, both of them. Now what I want to do now is to, now don't forget, this is like this force is acting at this point. This is also acting at this point. So if you have multiple forces, or let's say more than one force that is acting on the same point, you have to resolve to both horizontal and vertical. So this is the vertical part of Q2. The horizontal part will be traced like this. Let me explain this better. If I'm moving like this, indirectly I'm moving on both x and y axis. Right? Because if I get to this point, if you trace it to x axis, there is a movement. If you trace it to y axis, there is a movement. If I get to this point, if you trace it to x axis, see there is an increase. If you trace it to y axis, there is an increase. So this slant height has its motion on both the x and the y axis. So this is the x axis. So this arrow will be like this on the x. This arrow, because it's upward, it will be like this on the y. Do you get? Because it's pushing it upward. Are we together? Now this one now is pushing Q3 downward. So also put this. So this arrow like this is like this, while this arrow is like this here. Can you see? So now we are going to split, where's duster? Now we are going to split the diagram into two. Now, this first part now, let's say this is it. I'm coming. These are Q1. Let's say these are Q3. This is the arrow. So let's draw the second one, the one down here. Don't forget this is the arrow. So let's draw the second one. Sorry. This is the second one. It looks like this. This is Q3. This is the arrow. This is the arrow. Are we together? Yeah. Anyhow, we can draw it like this too. I hope we are clear with that, please. I hope we are clear with that. So I think there shouldn't be a problem with that. I feel like coming again. So that everything can make sense to us. If you've understood, fine, just keep your attention. Now we have Q1 at 0 and the y is 0.3, Q1. Q2 is 0 and minus 0.3. The x is 0 origin. The y is minus 0.3. So this is Q2. Q3, the x is 0.4. X-axis 0.4. Q3. The y is at the origin. So join the two together. So are we together? All the charges, they are positive. So the force exerted by Q1 on Q3 is a force of repulsion. So it's pushing Q3. The force exerted by Q2 on Q3 is also force of repulsion. Because they are like charges, also pushing Q3. Are we together? So now, draw the horizontal axis for this guy, because as this one is going like this, eventually it's going on both the x and the y axis. So the arrow will be like this, this will be like this. Now bring this part out, this second part. Bring it out like this. Are we together? Now these are Q2 and these are what? Our Q3. Now this first part, bring it out like this. You know, this is down, this one also will be down. So this can be like this. Or no. So draw the x-axis for this guy. So because this arrow is like this, so this place will also be like this, and this one will be like this. The direction of the arrow must be on the same direction. This is down, so this like this. So because this like this will be like this and like this. So this one, the x-axis is this. This is the slant. This is Q1. This is Q3. Then this is the y-axis. I hope the diagram I think is clearer now. Yeah, I think it's clearer now. Now what we are going to do now, the next thing to do now is, now we need to find the force first. The force exerted by Q1 on Q3, the force exerted by Q2 on Q3. Like on this line, we now resolve them. Now using the Coulomb'S Law, F1 on 3 equals to KQ1 Q3 over what? R squared, right? Magnitude. Our K is 9 times 10 raised power 9. What's our Q1? 2 micro. That's 2 times 10 raised power minus 6. What's our Q3? 4 micro times 4 times 10 raised power minus 6. What's the distance between Q1 and Q3? Don't forget this 0.3. This negative 0.3, which is still 0.3. You know, we already placed it on the negative axis. So you don't need to put this minus. This side is already negative. So what is this x? 0.4. So, but we need this distance between Q1 and Q3. So if you use Pythagoras, hypotenuse will give us hypotenuse square is equal to opposite square plus adjacent square. This place will give us 0.5. If you use Pythagoras, see this triangle, 0.4, 0.3, this will be 0.5. So 0.5 square. The distance between Q1 and Q3 is 0.5. So that's 0.25. So now, this minus 6, we cancel 6 here. Here we have 3 left. This 3 will remove minus 3 here. Here we have minus 3 left. So what we have left now will be 9 times 2, which is 18. 18 times 4, that's 72. So this guy gives us what? 72 divided by what? Is 0.25. Are we together? So let me press the calculator and see what we've gotten. I hope there is no mistake. Yeah, there is no. So 72 times 0.4 meter. Can you just give me a few minutes? 72 divided by 0.25 rather. 72 divided by 0.25. So that's equals to 288 Newton. Oh, sorry, 72 times 10 raised power minus 3. There is times 10 raised power minus 3 here. So 288 times what? 10 raised power what? Minus 3. Equals to 2.88 times what? 10 raised power minus 1 equals to 0. What? 288 Newton. So that's force exerted by Q1 on Q2, 0.288 Newton. Now force exerted by Q2 on Q3 will also give us the same thing. Why? Because both Q1 and Q2 are 2 times 10 raised power minus 6. And Q3 is this. So if you do Q2 on Q3, you still get the same answer. So this is F13 is same thing as F23 equals to 0.288 Newton. So that's that. So this 0.288 Newton is, so we have our force here 0.288 Newton. You can also put it as 0.288 Newton. You know, the force is on this line. You can put it here. These are distance. So we are not dealing with distance. We have done with the distance. So 0.288 Newton. So if you do this one until you get 0.288 Newton. So now the force acting on this line, this is it. This line, this is it. Because it is like this, so we have to result it to both horizontal and vertical. And that's our main focus. We are done with this diagram now. We have to resolve the force to both horizontal and what? And vertical. We have to know the amount of this force that is acting on the y-axis. Don't forget how we derive this direction. They are very important. Amount that is acting on the x-axis. This one is downward. So this is negative y. You know, we brought this diagram out of this side. It looks like positive, but because the arrow is down, the arrow is towards negative. So whatever you get there is negative. Not because of the side it lies on. It depends on where the arrow is facing. You know, the arrow we got on this positive y before is facing down. So our value here will be negative because it's facing the negative y-axis. So the negative part, the arrow is upward. It's facing the positive x-axis. So our value will be positive y-axis. So now, our distance here then, don't forget this place is 0.3, right? This place is 0.4. How do I know? You know this side was 0.4 before, and it's parallel to this place, also 0.4. So now we need to find the amount of force. And first of all, we need to find our angle rather, using the distance. No, this is force. This is force that we find. The force acting on that line, on Q2 on by Q2 on Q3, by Q1 on Q3, the force acting on that line. But before then, let's find the angle. This angle, and this angle. Let's find it first. Do we get this? You know, these are our dotted line. You can also find this angle. You can find this angle. Any angle you use, you still get your answer. If you find sine of this angle, it will give you cosine of this angle, and both answers will be the same thing. So any angle you find, you still get your answer. So let's find this angle using the distance first. Then whatever angle we get, we now use it to find the part of this force that is on both x and y axis. Now at distance, let's say these are angle theta, right? So this would be like let's use our 0.4 here. Can use our 0.4 here. Anyhow. So the adjacent, this 0.4 is the opposite, it's parallel to this place. So we can say tan theta equals to what? Opposite over what? Adjacent, 0.4 divided by 0.3, which is 4 over 3, which is 1.25. So tan arctan theta equals to arctan 1.25. Can use cosine, you can use sine, it depends. You know, we have a distance of 0.5 here before. If you want to use that distance, this place will be hypotenuse and what? An adjacent. You use cosine. If you want to use 0.4 in this place, that will be sine. So you can use anything, you still get your what? Your answer. So let me find tan inverse of 1.25. Tan inverse of 1.25. Arctan 1.25. So that's what? 51.34 degrees. So we are almost done. So our angle is 51.34 degrees. Are we together? So now, we don't need the distance anymore. So now, the amount of this force that is on x-axis and on y-axis. So let's check. No, this force is hypotenuse. So let's say our y vertical. Our y here. Let's say, what did I even want to put it there? Okay, let's find our y sharp. And this hypotenuse, the force is on hypotenuse. We want to know the amount of this force that is on the y-axis. So here we are going to get the y is adjacent. Adjacent and hypotenuse, that's car. So we are going to get cos 51.34 cos theta equals to what? Adjacent over hypotenuse. Y divided by what? 0.288. Are we together? So here now you have your what? Y equals to what? 0.288 cos what? 51.34. Y1, let's call it Y1. Are we together? Now let's find our X1 too. So let's say this is our X1 now. X1 here is okay, let me use down here. They are parallel, you can use any of them. X1 here is opposite to the angle, right? It's opposite. And this is hypotenuse. So that will give you sine 51.34 equals to x1 divided by 0.288. So we have x1 equals to what? 0.288 sine what? 51.34. Don't forget, anything on the y-axis we call it j, x-axis we call it what? I. So we find our y1 and x1. Now we are done with this guy. Let's not confuse us. Let me rub it. Now with this guy, this y2, this x2. Our y2 is adjacent, while the force acting on that line is hypotenuse. So our cos, the angle still remains the same, cos 51.34 equals to adjacent y2 divided by what? Is 0.288. So our y2 equals to 0.288 cos 51.34 j. This one now is upward, it's going to the positive y-axis, so this will be plus. The first diagram, the y part is facing downward, so here we are going to have minus. The x is facing this side, both x are facing this side, so x will be positive. X2, if you want to find x2, we will get sine 51.34 equals to x2 divided by 0.288. So x2 will give us what? 0.288 sine 51.34 I. See y1. Y1 is negative because it's facing down. Y1 and y2, they are the same value but opposite sign. So if you are summing everything together, this will cancel out. If I see this and I already know to cancel, I won't bother to work it. I'll just focus on the x alone. But I'm doing it in case you will have some that will not cancel out. It's cancel out because Q2 is same thing as Q1. So y-axis will cancel out. But let me not cancel it yet. Let's find our total force. Our total force now. Total force on y-axis equals to y2 plus y1. That's this plus this. It will give us a 0j if you had them. Total on x-axis. x2 plus what? x1. Let me find my calculator. 0.288, sorry. 0.288 sine 51.34. 0.288 sine 51.34. That is equals to 0.225. That is 0.225 plus, no, both of them are the same and both of them are positive. 0.225. X axis is y. So this one gives us what? Is 0.450I. 0.450I. Are we together? So now that is the force. The force on the force acting on Q3 by Q1 and Q2 are this. Now let's find it. If you want to find the magnitude of the y-axis, root 0, everything is still 0. The magnitude of the x-axis is going to give you square root of what? You want to find the magnitude. Notice I. If you want to find the magnitude, the coefficient is 0.450 squared. So the answer is still equal to 0.45 Newton. Assuming there is also y-axis, this square plus the square of these two, then gives you the magnitude. So this is the force exerted by Q2 and Q1 on Q3. Please, if this is not clear very well, let me know. Drop it on the comment section, please, if it's not clear. Or you go back to the video again. So in our next class, we are going to deal with electric field from scratch, and we will touch dipole in same video. Thanks for watching. And we are not done. To the x-axis. To the x-axis. Because the y-axis cancel out. The y-axis cancel out. And even some cases, if it doesn't cancel out, you can check which one is bigger, which one will overcome. If the one on the x-axis is bigger than the one on the y-axis, at the end of the day, it will be shifted more to the x-axis than the y-axis. But for now, let's just, when we get to such questions, we'll deal with them. So this to the x-axis. So that's just it, because the y-axis was cancel out. So thanks for watching.